Thank you very much for coming to this session. Today I'm going to show you the microservices Spring Boot development in the context of Kubernetes. My name is Soto. I work in Red Hat. I'm the curator of loftofthejars.com, and also you can, if you have any question or any comment, you can just ping me on Twitter, and I will try to answer your question as soon as possible. Also, I'm the co-author of Testing Java Microservices, which if you buy today, you have this discount of 40% of discount of the price of the book. And please, if you have any question, just feel free to just interrupt me when you have the question, or just wait at the end. I mean, it's not a problem for me. Also, I'm going to just warn you that everything that I'm going to show you is open source. In Red Hat, everything that we do is open source, so feel free to use. As I said, I'm going to introduce you microservices. Probably most of you knows what is a microservice, but just a simplification, let's say that it is a small piece of software that offers a specific feature. This is my service, which can be implemented with several languages, like JavaScript, or Java with a Spring Boot Vertex, or Golang, or Wildflower Swarm if you are in the Java EE space. But microservices also have all these, I like to say, cross-cutting concerns. For example, discovery. You have several services, right? And you need to know where all of them deployed. There is the API to interact with the service. There is the invocation. You need to know how to invoke this other service. There is elasticity. Each of the microservices must be elastic in the sense that if you have a high level of traffic, then you must be able to replicate this service in several parts of the cluster. Resilience. What's happening if your service goes down? Then someone needs to boot up again. Or even more important, what's happening when you have really a lot of traffic, that the service, it seems that it's died, but it's not dying. It's still there, but it's receiving a lot of requests. So you need to deal with this. Also, pipeline. All your microservices must be automatically deployed. There is no manual steps. Authentication, not just in the API gateway that you usually have all the authentication things, but also between service to service. Logging. Monitoring. You need to know what's happening with all your microservices. Finally, tracing. It's really important to know when a request reaches your application, what's going on with this request, how it's going through all your services, and then it's returned back. And the big problem with this, with the microservices, is that all these cross-cutting concerns are inviting your business logic. So usually what you are doing is just implementing your business logic plus all these features, right? And I'm going to talk it later how to avoid this problem. So we can think that in 2014, well, maybe some of you say, yeah, I'm still doing this, but I mean, just to put it some data and everything, you are using Spring Boot to deploy or to develop your microservices, and then you use Raven, Eureka, Config Server, Caillou, Zipkin, Zool, and Hystrix. One thing that's known as Netflix OSS, and then you wanted to deploy all these microservices inside a Docker container. And I would say that Docker container is just awesome, right? Because it allows you to define all your stack in just programmatically in just one place, in the Docker file. So you go in your Docker file and say, I want to use this operating system with this Java virtual machine. Even you can specify this minor version, the 144. It's really important. Sometimes you change this last number from the JVM in production and, for example, in your computer, and then you have some problems. Although, you know, they say that there is backward compatibility, but it's not true. I faced some problems with cryptography algorithm in this sense. Then you can add your custom configuration with JDBC drivers, JMSQ, maybe the users that you want to run this application. And finally, you have your jar file. So you define your Docker file, and then you do Docker build, and then you have all your container ready to be deployed. And notice that this is really different of how we work in the past. I remember working in one company which we are creating a war. We do, you know, in the Jenkins, we do the war file. We put it in Nexus, and then we send an email to some ops guy and said, hey, guys, I have a new ward that we need to go to the production, so please deploy it, and this is the list of instructions to deploy this ward to production. Just copy this ward inside, I don't know which directory, open these ports, and so on and so forth, right? And then it was like, it's not so good. And then I moved to another company, and I arrived to this company, and I asked them, hey, how are you deploying your WAR file? And they said, oh, no, we are really smart. We are using a wiki page. And it was like, OK. It's exactly the same, because at the end, it's a page that the first day is updated, but then after 10 days, it's updated completely, and it's impossible to follow these instructions and deploy something to production. So this is something that Docker is really awesome. The problem with Docker is that how we deal with multiple containers, right? I said that if I have a service that must be resilient, and means that it must be scale up and down, depending, for example, of the traffic, or if this is crashing, right? So how we can scale several containers, how avoid port conflicts. At the very end, your server is running in a machine, and this machine has ports. So what's happening if all my services runs in the 8080 port? How we can keep all these containers running? If one container dies, who is the responsible of booting up again? So one of the solutions was like, OK, I have my cluster with several machines, and I'm going to do SSH Docker run, and I put there my Docker container, SSH Docker run to other cluster, and so on and so forth. So you have a guy or a machine that is just doing Docker run, Docker run, Docker run all the time. This is a way of doing it. But of course, the solution is Kubernetes, right? Probably most of you knows what is Kubernetes. Just as an introduction, Kubernetes means governor or helmsman. I mean, that is the pilot of the ship, right? So if you know Docker, Docker is, this is the logo that is like a ship with containers atop. Then we need someone who rules this ship, and this is Kubernetes, which is a container orchestrator, which is written in Go, but it doesn't matter at all. And and allows you to manage applications and not machines. And it's really awesome, because you can just take your service and say, look, I want to run 3 instances of this service on my cluster. I don't care on machines. I don't know if this machine is here, or it's 1,000 miles away from here, or it's this IP or this other IP. I don't care. I want this service deployed automatically and always keep it alive. And this is how a Kubernetes cluster looks like. Usually you have the master, right, which is the etcd, API, scheduler, and controls, and so on and so forth, which is the one who manages all the clusters. And then we have these minions, or nodes, where is the real machines, right? Well, at the end, they can be virtual machines, but let's call it machines, which they have some spots where there is some services running. For example, I can say, I have my application with JavaScript, and I want to run it 3 instances, and then please, Kubernetes, take care of having all the time 3 instances in my cluster. Then you have Tomcat, Postgre, Mongo, or whatever. So the Kubernetes itself takes care of managing all these things. Just for those who don't know or have a basic knowledge of Kubernetes, I like to show this slide always, because it offers the key concepts of Kubernetes. The first one is pods. For those, that this is something that probably most of the Catalan guys here will understand. For me, a pod, it's like a jar, because in Catalan, pod is a jar, right? And I was thought that it's a jar where you put containers. But then one day I discovered that pod is a group of whales. And you know that Docker is, that the logo is a whale, so you can consider that a Docker container is like a whale, so a pod is a group of whales. So it's a group of containers which shares the IP, the storage volume, share the resources, and the life cycle. So if one container of the pod dies, then all the containers inside this pod dies as well. Then we have the replication controller of deployment, which basically is like you can think about like a daemon, right? That it just ensures that the specific number of pods and replicas are always running. So it's like a daemon that says, you told me that you want 3 instances of this pod running. Are all of them healthy? If yes, I do nothing. But if there is one pod that it's misbehaving, then I will say, OK, this pod, it seems that it's not working very well. So I'm going to kill it and start it again, a new pod. Then we have services. As I said, a pod is something that is ephemeral. It can be there or not, and of course, each pod has an IP. But how you as a service can interact with another service is not by just making the request directly to the pod IP, but just to a service. Service is a IP that it's always stable, and it's like a load balancer across all the pod instances. And finally, we have labels. You can put labels everywhere, but basically it allows you to associate concepts. And for example, this pod is for production, and this pod is for pre-production. For example, you can add some custom properties to these elements. So how you deploy something to Kubernetes? This is a simplification, right? But basically, you have your code. In this case, it's a Node.js application, but it doesn't matter. I mean, it can be a Spring Boot application. Then you need to create a Docker file, right? Because Kubernetes only can deploy Docker containers, so you need to define your Docker file with all these commands. Then you need to build this Docker inside a registry that is accessible from the Kubernetes side. So if you have your Docker registry running inside the Kubernetes cluster, then you need to somehow configure your Docker build command to just build and push this image to this Docker registry so cluster can use it. Then you need to create a deployment.yaml or call it whatever you want, but you define your application with labels and even which is the container name, the container port, and so on and so forth. So you also need to do this deployment.yaml file. And finally, you do kubectl apply -f hello deployment.yaml, and that's all. Just with this, you have your application running inside Kubernetes. That's, let's say, the way of doing it, but what I'm going to show you now is another way. I have here a really cool application. We just write this. It's done in Java. I mean, I know that everyone now is moving to Kotlin, but I've been programming with Java almost from the beginning, and 2 months ago, I started learning Go. So yeah, I know that I can learn another language, but for now, Java is fine for me, which just notice that it returns a string, which is the host name where this application is running. And that's pretty important because at the very end, the applications are running in a physical machine. So how we can deploy this to Kubernetes? Well, it's really easy. You can do all the steps that I showed you before, or you can use FMP. FMP means Fabricate Maven Plugin, which is a plugin that I know that it's opinionated configuration plugin, which generates a Docker file for your application, a deployment YAML for your application. It allows you to push automatically to your Docker registry running in the cluster, and so on and so forth. And everything is automatic. Of course, I'm going to show you, and I will explain you more about this. Wait. So this is where is my application, and I do clean, fabricate, deploy. I just run this. Then it's compiling, creating the jar file. It's generating all the resources, and then start to build the Docker image, pushing into the Docker registry of the Kubernetes cluster that I'm running locally, and then deploy the application. So that's doing some things. So the good thing about this is that you can just rely on the defaults, which, as I said, they are opinionated, but I must say that it works in the 90% of the cases, but also you can configure how you deploy your, your deployment file. So you can say, I'm okay with the default files. Notice that it has finished, but I will show you now. Just use the default ones, but append this part to the file, and you only need to define this small part. Or you can say just use the defaults and also all these files. So you can also define your own files, or you can just say skip the generation part and provide me the files that I want to use to deploy. So now if you see here, this is my cluster, and you can see here that Hello Boot is running with 1 pod. I'm going to scale it to 2. So now I have 2 pods of Hello Boot running somewhere, and then I can do a call Hello Boot and say that hello from Hello Boot, and it returns you this hello boot 128Z74, and as if I do kubectl get pods, you can see that there is 2 pods, which one of them is that one that is returning. So it's really easy to deploy. You see, my application is really simple, I know, but there is no Docker file, no deployment YAML file, no kubectl interaction, nothing. It's everything done automatically. Also, you've seen this is a Spring Boot application, really easy to deploy. Also, there is one extension that is called Spring Cloud Kubernetes, which basically offers you an integration with a Spring Discovery client. This is something that comes, I guess, from a Spring Cloud, and allows you to, instead of using the default client, use the Kubernetes Service Discovery. So you can use the Kubernetes Service Discovery as a Spring Discovery client in your Spring code. One thing that is really powerful is this config map property source. With Kubernetes, is one thing that is called config map, which is the way how you can configure from infrastructure point of view an application. So you can say, this is my configuration, and if I change this configuration, this means that I'm going to redeploy again the service. And how you can get this config map from the application, it's always a bit tricky, but with a config map property source, you can use this Spring property source to just inject into your code a config map or a secret. And finally, if you are using Zipkin, you can for tracing all your requests, then you can use Zipkin Service Discovery, which is another part of Spring Cloud Kubernetes, for using Zipkin inside Kubernetes. This is a really cool project that helps you in integrating with Kubernetes. So far, now it's 2016, a lot of companies, banks, insurance companies, and so on are moving to Kubernetes. The truth is that traditional business are moving to this, and we have that thanks of Kubernetes, now you have my Spring Boot application, but I don't need any more Ribbon or Eureka or config server, because all these parts are managed by Kubernetes. So you can drop all these libraries from your class path. Of course, you still need Archaeus for managing the configuration, Zipkin, Zool, and Hystrix for resilience of your application. But it's a step forward using Kubernetes. But you've seen here a really simple example that I just did Maven fabricate deploy, and my Hello World application is deployed. That's really easy, always works, right? It's a demo. But how you can really release something to Kubernetes? And there are several ways of releasing in general, releasing a software, or more specifically in Kubernetes, which is really easy to do it. The first one is like blue-green deployment. It's like, I have a blue service, I release a new version, and then I switch to this new service. So I have my build, I deploy my build, which is at the end is a Docker container, into production, and then when I'm into the production, all my traffic goes to the blue service, and when this is inside into the production, I said, yes, it's good, it seems that it works, it's been deployed correctly, and so on so far. Then I switch all the traffic from blue to green. Then I start monitoring my application, and if I see that there is no 500 errors, for example, it's like, okay, it seems that everything is working as expected, so I can destroy the blue service. But what's happening if it's wrong and things are behaving unexpectedly, then I can just quickly switch from green to blue, and that's all. I'm still with the old version. This is one way, called blue-green deployments. But there are others. Another one is that Canary releases. If you notice now, I have, or in the previous example, I have like blue and green, and I switch the traffic from blue to green, and what's happening if the green is wrong? All my users will start getting all these errors. So instead of saying, yeah, I know that it will be like 10 seconds, but it will be 10 seconds that all the users that are using your application are going to be really angry, right? Then there is Canary releases. And Canary releases is something that comes from coal mine. And basically in the coal mines, literally, they take a bird, a canary, right? And they put this canary inside the mine. As the bird drop over dead, then you know that you have a problem. And then you need to go out from the mine, because it means that inside the mine there were some poison gases. So yeah, the idea is exactly the same in the software, but of course you don't need to buy any bird or canary, because you just have your service, your new service, all your traffic goes to the service blue, and then you put your service, you deploy and your new service to the blue part, let's say, and you just send to this new service 1% of the traffic. So you have 1% of the traffic, you monitor your service. If everything is okay, then you say, okay, now I'm going to just try 5%. If it works, maybe 50%, 70%. All 100% of your traffic then goes to the new service. So it's like, okay, I don't want to move all my users to the new version because I don't know if it's going to work or not, but instead of this, I'm going to just send 1% of the traffic. If 1% of the traffic goes okay, then I'm fine. But if not, if they die, like the canary, then I know that I need to switch back to the old version. But there is even more strategies, they are called dark launches. This is, in my opinion, the best one. Because now, notice that if you are, for example, Twitter, 1% of all the users are a huge amount of users. So again, if you have deployed something wrong, a lot of users will get these errors. And this is something that you don't want. So there is dark launches. Dark launches are like a family of ways for testing your application on production without the end user noticing it. And here I'm going to show you two strategies. One is called dark launches itself, which is like I have my green service, all the traffic goes to the green service. But then I have some internal users. Maybe if I'm using my own application on my company, then I can say, okay, now all the users of the company that is using my product are going to try the new version. So if it's wrong, it doesn't matter, right? I mean, that they are employees, so they can just notify us, hey, something is wrong. But nobody from outside will notice it. And another way, which is really powerful, is shadowing traffic. This is slightly different. And it's like, I have my users, and then what I do is like, I send two requests. One request to the real service, let's say the B1 service, and then I send as well this request to my new service. But there is a different. Notice that the arrow in one is bidirectional. It means that the request, the response that will receive the user, is the one that comes from the B1 service. So the V2 service is just a find and forget request. But the powerful thing is that I can monitor the green service and say, okay, all my users are testing my other service, and it seems that it's behaving correctly. There is no 500 errors, no 404, nothing. So then I can start doing the canary release. So there is always a step before we release our software to the public. And now you're wondering, okay, you're talking here about, shadowing traffic, sending some traffic to one service, another traffic to another service. And of course, for the demo you've shown, and usually in all the sessions that you go to a conference, always work because it's really simple, right? There is no state. You return something. But what's happened when I have, for example, 3 pods of the service V1 and 3 pods of the service V2, and I'm starting moving traffic from V1 to V2. What's happening, for example, is if I have a shopping cart, and I'm a user that I'm in the V1, I'm going to start adding some elements in my shopping cart, and then someone from DevOps starts moving traffic from V1 to V2. If I reach V2, what's happened? I lost my shopping cart, so I need to re-add again all my elements, all my items. And to fix this, I mean, there are several strategies, but the one that I really love is like using a Spring Session. I think that there was a talk yesterday about a Spring Session. and InfiniSpan, which basically what it does with the Spring Session plus InfiniSpan is that you maintain the state across all the cluster. So all your services always knows exactly what's happening. And in this way, you can put there your shopping cart. So it doesn't matter if you are start switching traffic from A to B, because your shopping cart is always available for all the services in the cluster. And I'm going to show you here a demo about this. It's a really interesting demo. This is the store. Then I can go here. Now I have one version deployed. Here it is. Okay, this is a shopping cart for movies. So now please, I add Deadpool 2, yes or no? Yes? One copy? Okay, one copy. Thor? Yes, no? Well, yes, okay. Solo? Yeah? Okay. And Guardians of the Galaxy? Yeah? 3 copies, for example, okay. Then I can see here my card, where you said Deadpool, Solo, Guardians of the Galaxy, and Thor Rangot. And an important thing here is this. This says who served this shopping cart. If I go to my console and I do OC get pods, or kubectl, sorry, get pods, you can see that there is 2 pods of this movie store. One is the 4N and the other one is LF, and here it served me for the 4N. So this is the pod that is containing all my shopping cart. And then you said, okay, now I want to release a new version, which we can do it easily. I'm going here. This is also a Spring Boot application with Themeleaf. And then I go, I think it's resources static. No. In the cart, I'm going to change my movie cart to my Spring.io movie cart, right? And then I'm going to deploy this as I've done before using Fabricate Maven plugin. Okay. Then it's doing exactly the same as before, generating all the stuff and deploying this to the cluster. In this case, it takes a bit because it's not, it's not a hello world application. It's something more complex. But now it's pushing all the layers, all Docker layers to the Docker registry, and then it's a success. And then if I go here, you can see that I have my movie store, which is the one that is running, and then the store Canary, which now it has 0 pods. I'm not sending any traffic to there. Then what I'm going to do is just increase to 1 pod, and you see that now it takes a bit time. Now it's like this light blue. It's because it's just starting. And it will take some time. And the reason is that because this instance, it will be ready when all the InfiniSpan that it's inside is updated with all the data that it has all the InfiniSpan instances. So it is something that is really cool from Kubernetes that can be done, that it's this liveness and readiness proof. So you can say, please Kubernetes, don't send traffic to this instance until I am ready. And this I am ready, it's implemented as you want. And you can go, if you want to see if you are, how this is, I am ready, it's done in here, I guess. Wait. Controller, home controller. Here I have an endpoint, which is called healthy, which just returns an OK, an HTTP status OK, when all my InfiniSpan is ready. At that point, then Kubernetes will say, OK, now I can start sending traffic to this instance. And now I can go here. I'm going to just suppose that now some traffic are going to this Canary. I'm going to remove all the pods, the all pods, right? Suppose that everything goes as expected. So now I've scaled down all the popular movie store where I added all my movies. So maybe you might expect that these movies will be lost. But now I can go here, I refresh, and if everything goes as expected, see that there is no change. My movies are still there, but now, review this. This is a different pod. Now it's like popular movie store Canary, PVT, blah, blah, blah. Which if you check here, if I do a kubectl get pod, you see that I have only one pod with this machine. So now I'm able to maintain the state across all the Kubernetes cluster thanks to a Spring Session and InfiniSpan. I think that's a really cool example. But I want to show you something that I remember Josh in the previous session said, hey, but we want to use the future, right, not the past. So in 2019, all my microservices is going to be something like this. No Netflix OSS, no Eureka, no Istrix, no Ribbon, nothing. Everything managed by Istio. So the question is, what is Istio? Istio is a service mesh. It's a family of service mesh platforms. And a service mesh is like a layer in your infrastructure layer which assures that all your communication between service to service can be done in an easy way. And basically, Istio is a Greek word for sale. Again, this thing for Kubernetes and so on and so forth. It's a fleet configuration. It means that it's like you can think of like a service which configures all the communication that happens within your Kubernetes cluster. Basically, you can change routing and load. You have routing and load balancing control. You have observability, which means that by default, Istio comes or have an add-ons for Prometheus, Zipkin, Jaeger, and so on and so forth. So you can observe what's happening in your infrastructure out of the box without requiring any installation. It also can be used for chaos testing, and also it has security options, which is really powerful because you can configure that from service A, the communication between service A and service B happens with HTTPS. But the thing is that your services didn't know that. Your services still are your business code communicating with HTTP. And then with Istio, it intercepts this call and adds an HTTPS layer, and also helps you to maintain automatically all the certificates, all the certificate rotation, and so on and so forth. So it's really powerful for securing your services. And this is the schema or how it works Istio. You see here that you have your pod with the service A, that if you say Spring Boot, it's running in JVM. Then you have your container, and then you have your pod. And remember that I said that a pod might contain more than one Docker container. So now we have two containers, one which is my application, another one which is this Envoy sidecar, which basically is an Envoy proxy. It's a proxy that intercepts all the traffic that enters into the pod and goes out from the pod. So when you want to send a request between service A and service B, what's really happened is that your Envoy service is intercepting this and send the request to the other Envoy proxy, and so on and so forth. So all the communication happens through this proxy. And then this is called the Istio data planner. But then we have all the Istio itself, let's say, which is the Istio pilot, which is like a service that receives all the requests and response for configuring all these Envoy. So you need to configure that service A talks with service B, or if you want to switch that the service A send request to service B V2 instead of V1, and so on and so forth. So you need to do all these things with Istio pilot. Then you have Istio Mixer, which is like for doing the telemetry. All these observability things are implemented here, and the quota for setting some quota between services, run limiting and ACLs. And then you have the Istio Auth, which is the part responsible for managing all the HTTPS communication between services. So how you can do a canary release with Istio? It's really easy. And there is no manual step at all. It's just a YAML file. At the end, it's a Kubernetes resource where you said, look, I have a service called recommendations, and I want to, and when any service from my cluster wants to reach recommendation service, I want to send 90% of the traffic to the V1 and 10% of the traffic to the V2. Just like this. You just send this, or you apply this file to the cluster, and then everything magically, without having to redeploy anything, nor modifying your code, nothing, it will start working. Let me show you an example about this. I have now, let me move to here. Notice now, and I'm going to generate some. Notice now that what I have here is like a service called customer, another service called preference, another service called recommendation, V2. And then I did another request, and it says customer preference recommendation V1, and then V2, and then V1. Because by default, Istio just do a round-robin load balancing. So it's like, I have two services, recommendation V1 and two versions of the service, recommendation V1 and recommendation V2, and I'm going to just start splitting traffic from V1 to V2 in the request. Now, you said, okay, now I want to send all my traffic to V1. So the only thing that you need to do is Istio-ctl, create -f, root rule. I have here the file. Okay, this is the file that I can show you in a moment. Then I just do this, and now notice what's happening when I do execute. All the traffic only goes to V1, never to V1, V2, V1, V2. And I have not deployed anything. I have not changed my code, nothing. It's everything managed by Envoy and Istio. Yeah, I can show you if you want this file. Notice that what I'm saying here is really simple. I'm just saying when someone needs to reach recommendation service, send all the traffic to V1, release them. Now suppose that I want to do a canary. Now I've deleted the previous rule, so now I have again this V1, V2, V1, V2, V1, V2, and then if I want to start doing a 90-10, then I just need to do Istio-ctl, create -f, this one. And now if I run again execute, you see that there is a lot of V1s and sometimes, like for example, here, here you can see that there is V1, V2, and then a lot of V1s because it's the 90%. Suppose that now you are monitoring this, and you said, yeah, it's working pretty well. Let me move to, for example, 75-25. So the only thing that I need to do is Istio-ctl and replace. And I'm saying that the previous rule must be replaced with this new rule, which is a 75-25. I apply it. Let's say that it's updated, and then I can do execute. And now V2, now. Notice that now V2 appears in more frequent than before. You're going to start moving and moving with Istio-ctl how all your traffic behaves. What I've told you before about observability, you can see that in Istio, I have here a Grafana that it's out of the box, they're implemented for me. I've not done anything, I've just installed Istio, and then all these things come. And I have here all the Istio, and the success rate, and so on and so forth. So if I see here, for example, that the success rate when I deploy something start decreasing to, for example, 80%, when in the past was 100%, then I know that the new version is worse than the previous one. So you see Istio, this is how we are going to, or how we should deploy and release in 2019. Let's win down. Notice that at the beginning I started with this, and I said, probably nowadays you have all these cross-cutting concerns implemented inside your service, inviting your business logic, but now with Kubernetes Istio, you are almost fixing all the problems. And if, for example, you're using OpenShift, with OpenShift is Kubernetes for enterprises, which is open source as well. You have the pipeline and the login also covered. Also, I know that it's really cool, for example, the demo of shopping cart and so on so far, but this is not like you have to go to Kubernetes from one day to another day, because it's like Kubernetes is not is a tool, but it's not to be used as a tool. It's more like a philosophy, let's say. You need to, before moving to Kubernetes, probably you need to reorg your organization to DevOps. Then you will start saying, okay, now that I'm able to cut my time from when I have an idea and this idea goes to production, when I have shorter time, short lead time, then I can move to a self-service on-demand elastic infrastructure, then I can move to automation, Puppet, Chef, Ansible, Kubernetes, and this is when you have to introduce Kubernetes, not before. I mean, of course, you can always add Kubernetes at your company, but you will use all the full power of Kubernetes if previously you have done these steps. And then, of course, you're going to move to CI/CD deployment pipeline. When you have everything automated, then you can start doing these advanced deployment techniques that we have seen, dark launches, canary releases, blue-greens. And finally, when you have all these things clearly identified and running, then please move to microservices. Because please, don't think that if you move to microservices, you're going to be able to deploy daily if you are not being able to do it with a monolith. Of course, automate everything. Here I've shown you that all the parts are manual. I just run Maven, I just run Istio CTL, and so on so far. But of course, you need to automate everything. And that's all. If you are, you can send me an email if you have any question, or you can do it in Twitter. Also, if you want to know more about Istio, which is really a buzzword nowadays, I think that there was a workshop or a talk of Ray yesterday. So it's really interesting. So if you join to developers.redhat.com, then you can download this free book that is written by my colleagues Kristen Post and Soto, which is the Introducing Istio Service Mesh for Microservices. And that's all.